We will use a tool to learn how to program Arduino boards without having the physical board. The simplest tool available online is called TinkerCAD. So it is sufficient to write TinkerCAD to access this tool. The first time you have to access, you can access with a personal account and for instance with a social account, for instance Google. TinkerCAD can be used to design 3D objects and to make and to realize it with 3D printers, or for circuits. We will use this part of the program. To create a new program, just click on New and select Circuits. Here you can change the name of the circuits, for instance, example 1. And here you can select the components you want to use in your example. The first component we want to use is an Arduino board, but we won't use Arduino 1. We will use Arduino 1 with the breadboard. So select the component, drag and drop. You can also rotate it. And this is a good position to start our design. Next, we want to understand how we can read an analog voltage with an Arduino board. So we will use a potentiometer or trimmer, this component. We can rotate it and put it on the breadboard. So one terminal is connected to 5 volt, that is the red line, and we keep the same color. One terminal is connected to ground, black line, and the middle terminal we can connect it to, for instance, analog input, for instance, number 2, A2, and we will do it green. Okay, how does this component work? We can take a multimeter, and the multimeter has 2 terminals, negative, that is ground, so we can connect it to ground, and the positive terminal will connect it to the middle terminal of the potentiometer. So we will use again a green line. So how does it work, the potentiometer? We can click on Start Simulation, and we will read this voltage 5 volt, that is the voltage provided by the Arduino board with the red wire. But if you click on the indicator and you move it, you can regulate this voltage from 0 to 5. And it is equivalent to have a physical potentiometer and to rotate it to obtain an analog voltage value between 0 and 5 volt. So how can we read it with the Arduino board? Clicking here on the code part of the program, you can select between block programming, mixed blocks and test programming, and text programming. Text programming is the most difficult because you have to know how to write the code. The code is similar to the C language code, so it is a case-sensitive code. In our project, we do not use the built-in LED, that is this LED connected to pin 13. We will print the data on the serial monitor, so we will use serial begin 9600 bit per second as bit baud rate for the serial monitor transmission. And here we will define a variable, for instance, int analog data, to read the value from the potentiometer. So analog data is equal to analogRead HU. analogRead is the predefined Arduino function to read the analog voltage applied to the analog pins. The analog pins are A0, A1, A2, A3, A4, A5. So with this instruction, we take the value read from A2 and we store it on the variable analog data, because this value is an integer number. Next, we want to print this value on the serial monitor, so we will print analog data on the serial monitor. Next, since the loop is executed more than 1000 times per second, we don't want to print the data 1000 times per second, but for instance, we want just to print the data once per second. So we insert a delay of 1000 milliseconds or 1 second. If I start the simulation, to see the serial monitor, we have to click here, serial monitor, and we see we read a value 757. If I change the position, the value is 511. Change again the position, 164. If I put the potentiometer to the lowest position, I read 0. If I put it to the highest position, I read 1023. So this simulation shows us that the potentiometer reads values, integer values from 0. The board, Arduino board, reads values from 0 to 1023 when the analog input changes from 0 to 5 volt. So 0 volt corresponds to an integer equal to 0, 5 volt corresponds to an integer equal to 1023. This is because inside the microcontroller, this microcontroller is called ATmega328, is present an analog to digital converter with 10-bit resolution. With 10 bits, the maximum number you can reach is 1023. 2 to the power of 10 is 1024, but we start, the number starts from 0, so 1024 numbers from 0 goes up to 1023. Okay, so we read the integer value corresponding to the analog voltage. If we want to print the analog voltage, we have to transform this integer value into the corresponding analog voltage value. So what is the proportion? So we have when we have A2 is 0 volt, we read integer 0. So this is the analog data value. When HU is 5 volt, we read 1023. So we can write HU is equal, stands to 5 volt as analog data stands to 1023. This is a proportion, so we can solve it saying that HU is equal to analog data times 5 divided 1023. This is our formula. So if we define here a analog voltage, a variable called analog voltage, we can calculate the analog voltage using this formula here. Analog data times 5 divided 1023. I add here a float number because analog voltage is a real number. In fact, we do not use an integer variable, but a float or double variable. And also in the second member of this segment, we have to use a float number, or to say that at least one of these constant and variables is float. Otherwise, the operation returns an integer number, so not an accurate value. Now we can print the analog data, and we print some space to divide the analog data from the real data, so some space, and finally we print the analog voltage. And we go. So now if we restart the simulation, okay, there is an error. I have to close the comment here. Okay. So if we restart the simulation, we can see now that we read the integer number and the corresponding analog voltage value. I change the value, so I read the board, Arduino board reads 736, and it corresponds to 3.6 volt in input. If I put here, Arduino reads 511, it corresponds to 2.5 volt. In fact, we are in the middle of the scale. If I put the trimmer, I rotate the trimmer to this position, the Arduino board reads 184, that corresponds to 0.9 volt, and if I put in this position 0, and we read 0 volt. We can also insert the measurement unit. So if we want to insert also the measurement unit, it's volt, we can insert it here. And so we read also with the measurement unit. So now we have the reading of 409 that corresponds to 2 volt. And if I change the position, I can read different values. So with this potentiometer, we can regulate, for instance, the light of a LED, or also the threshold for temperature regulation, for instance. So we can do several things.